lesson about the proof for Tan Chord Theorem. Okay, we're going to start by explaining the proof. Tan Chord Theorem. Tan stands for tangent and chord stands for the chord. So a tangent, it's a line that touches a shape in one point. So in this instance, we're talking about the circle. And then a chord is a line that touches a circle in two sides but doesn't go through center. So this theorem is about these two lines, the tangent and the chord. Now, the angle between the tangent and the chord, you'll find that angle, this is my chord, and that's my tangent. So this angle that is formed here, that's the angle that we're going to talk about. And then the other angle that we're going to talk about is the angle that is subtended by the chord, meaning that the angle that is formed up in the chord, it starts where the chord starts, go to the circumference, comes back to the chord, that angle there. Right. According to this theorem, it says these two angles, this one and that one, are equal. So you can use this theorem to prove in a radar where they give you a question and then you prove things, or you can be asked to prove the theorem. So in this lesson, you're particularly going to be proving the theorem. You're going to be given a drawing like that, and then they're going to add alphabets for you so that you can name angles. It's called A, B, C, then we have a D and an E there. Every time when you are proving a theorem, you must write what you are required to prove. In this question, you are required to prove that angle D, B, C, that angle that is formed between the tangent and the chord, is equals to angle B, E, D. This is what you are required to prove, right? You are also going to be given a center O. Then you have to construct, meaning drawing things that are not in the diagram so that you can prove the theorem. If your construction is wrong, you get no marks. If you don't have a construction, you get no marks. So for the proof of a theorem, if you don't have construction, no marks. You're wasting your time in an exam. Rather move to the next question. The construction, you learn the construction, you memorize the construction. When you go to the exam, you must know Tan Chord Theorem, the construction is this one. This kind of a theorem, the construction is that one. So according to Tan Chord Theorem, you're going to draw a tangent. Not a tangent, you're going to draw a diameter. You write, draw a diameter. Then with diameter, you must name your drawing. Does look nice. Let's do that. Let's move E a bit so that you can see my diameter properly. Right, I'm going to construct my diameter. I have A, B, C, I'm going to go to F. Then my diameter is from F to B. Diameter, F, B. And then another construction, you're going to join. Join, E, F. This is very important, line E, F. If your construction is wrong, no marks. So you start getting mark, you get 1 mark when you have this. Then you start with the proof. With your proof, you need to know beforehand which theorems am I going to use. You're going to use 2 theorems. You're going to use a theorem, actually 3 theorems. You have a diameter, angle in the same circle, that's the first theorem that you're going to use. You're going to use a diameter and a tangent, that's your second theorem, and you're going to use angles in the same segment. Then you've done your proof. Because of my board, I'm going to rub here from the construction. Then I'll start with my proof. I'm gonna say, okay, now when I look at my proof, I have two angles. I'm gonna try and keep those angles. I have this angle DBC and angle BED. DBC, here's DBC. I'm gonna keep that angle. DBC plus this angle here plus that smaller angle there, which is called FBD, is equals to 90 degrees, and the angle is diameter, the reason diameter perpendicular to tangent. That's my reason, right? Now the angle that I wanted, this one, here it is B, where is this one? This one, here it is. So I'm gonna I have that. I am happy, and I go to the next angle that I want this one. This angle is there. This angle is formed by two. I have BED plus that angle that is from there, DEF, is also equals to 90. There is an angle in semicircle. Right. Now when you look at our diagram, we have these two angles that we're looking for, and they are equal to something and equals to 90. So if I can prove that these two angles are equal, therefore these two angles will be equal. The third theorem that we're going to use, angles in the same segment. Angle FEB, this one. FEB. FED, not BD. FED. Oh, here I've called it DEF. Let's keep the same order. DEF is equals to DEF, that angle there, is equals to FBC, that angle there. FBD. And why are they equal? The angles in a same segment. Now, if these two angles are equal, then it means the proof, we've done our proof. DBC is equals to BED. You don't write Tan Chord theorem. When you're proving a theorem, you don't write that theorem as the proof as one of your reasons. You don't do that. When you have done that, we are done with your question. That's your answer. That's your proof. Usually 5 marks in an exam. That's all you need. Thank you.